Thanks for coming, everyone. And this is Cara Parsons' final seminar for a PhD. And Cara's been looking at mature trees. And, in something we went to recently, Wally Bell, who's a Ngunnawal elder, I asked him, well, what are mature trees mean to you? And he said, they've got great spiritual value. So I'd like to acknowledge the traditional owners in the ACT, and I think Cara will extend that to others in areas that she worked in, the elders past, present and emerging. And I just want to acknowledge all your panel, which myself, even though I'm the nominal primary supervisor, really it's been a joint effort. I think John's done tons of work on this, and Saul, of course, and Darren, who's here from the ACT government, and for the bat stuff,
We also had
Brad Law came in as well, which was fantastic. So it's been a great joint effort, hasn't it?
Yeah, it's been great.
So without further ado, let's hand over to Cara.
Thank you. Okay, this is it. Yeah, so I'd like to acknowledge the Ngunnawal and Ngambri people of the Canberra region, as well as the Turrbal and Jagera people of Meanjin, which is the Brisbane region where I'm from. Okay. This is just a bit of a quick overview. So I'll just introduce my PhD as a whole. My PhD is being done as a series of publications. So we have tree retention new developments as my first paper. The birds and bat community response is 2 different papers, but I'm going to talk about them together as they share the same or similar methods, and they were conducted at the same sites. And then my 4th section is quantifying risk posed by Australian eucalypts and conclusions. Okay. To give a bit of an introduction, I want to talk about why mature trees are important. So what makes mature trees important for biodiversity? We know they are keystone structures in a range of different environments, including agricultural landscapes through to urban areas. We know they offer a range of features to make them attractive to wildlife, including lateral branches for resting, large volumes of nectar and seed, decaying heartwood, and especially in the Australian context, we need to talk about hollows. As Phil mentioned, mature trees also offer a range of ecosystem services, in addition to their social and cultural values. So mature eucalypts are of cultural significance for First Nations people of Australia, with many mature trees predating European settlement. We know large trees also offer shade, carbon sequestration, mental health benefits, and they mitigate the urban heat island effect. Additionally, property values will increase with the proximity of mature trees. Okay, following that intro, I'll introduce my research aims and the thesis structure. Do you like the scooter in the background? Yeah.
It's like the cockies, not the rider on.
Yeah, it's just like shows a nice little picture of Canberra, the beautiful cockatoos, and then some dead scooters in the background. Yeah. Okay, so my research aims. First step, we wanted to determine the patterns of retention of trees in residential development. We wanted to investigate how bird and microbat communities vary with the number of large trees in urban areas. We wanted to quantify the risk to people and infrastructure of retaining mature trees in different urban settings. And then using all that information, we wanted to identify how residential property developments can retain more trees safely while supporting biodiversity. So looking at my thesis, we've got the first paper has been published in Urban Forestry and Urban Greening. The second paper is Large Trees are Keystone Structures for Birds, and that's onto its second review with the journal. Large Trees are Keystone Structures for Australian microbats, and that's currently under review with biological conservation. And then my final paper is looking at an Australian version of the quantified tree risk assessment, and I'm finalizing the drafting on that one. Okay. So studies have recorded the loss of mature trees to agriculture and forestry, and by damaging processes such as changing fire regimes. However, residential development also represents a considerable threat to mature trees, one with little research documenting the extent of that loss. In this study, we quantified the amount of canopy cover retained during residential development. We identified where trees are or are not retained within residential developments, with an emphasis on mature trees. And we evaluated the effectiveness of current legal mechanisms for protecting mature trees during residential development. As a bit of a background, you can see in this table, we only have 3 Australian states and territories that list the loss of mature and/or hollow-bearing trees as a threatening process. Just that much area. For this study, we selected ACT, New South Wales, and Queensland to have a look at tree loss. Okay, so to investigate the aims, to address those aims, I investigated 19 residential property developments across those 3 states. We selected greenfield residential developments up to a maximum age of 10 years, stratified across jurisdictions that do or do not list the loss of mature and/or hollow-bearing trees. Out of the 19 developments, 7 were approved under EPBC approved conditions. The others did not need any special conditions at all. For each site, I would sample up to 40 trees using aerial imagery from Google Earth and Queensland Globe. Trees were measured for their canopy width and the pre-clearing extent. And then in post-clearing imagery, I'd use that to check if the tree was retained and under what land use. So as an example, we've got Harrington Grove here in New South Wales. So what happened was Harrington Grove has 139 hectares total. With the pre-clearing image in 2009 versus post-clearing in 2019. So out of the 40 trees that I measured, 18 were retained. And then across the whole study, we had 565 trees measured across the 19 developments. Okay. This is looking at the predicted canopy loss. So taking all of those tree measurements from the 565 trees, we'd look at if they were going to be retained pre and post development. So having a look at this, it's really clear to see that we have ACT as the first column, then New South Wales and Queensland. In Queensland, there is huge variation in the canopy cover, particularly compared to ACT, where there is very little canopy cover to begin with. However, ACT retained 54% of their canopy cover on average. So even though they are starting with a small amount, they are still losing about half of that. New South Wales retained about 65% of their canopy cover on average, and Queensland was only 39%. Okay. This figure indicates the probability of a tree being retained based on the best generalized linear mixed model as ranked by AIC, and they are split according to land use. So ACT does have the highest probability of trees retained, followed by New South Wales and then Queensland. Cool. Basically, we've got the blue is for remnant vegetation, the green is for green space, and then the other in grey indicates if the land use was something like a road verge or a residential block. So looking at this, we can see that the trees are going to have the greatest likelihood of retention as part of a block of remnant vegetation. And then looking at green space for each one, it does vary a lot. So ACT has a reasonable chance, particularly at the median, whereas New South Wales and Queensland, very much less likely. And that medium tree width no, tree canopy width does vary by state. Okay. Basically, all of those findings together means tree protection needs to be a forethought, not an afterthought. So considerable tree cover and mature trees lost during residential development, thus undermining the sustainability of residential development. The findings in this study indicate that consideration of tree protection needs to transition to be a forethought, not an afterthought. We recommend that the loss of tree cover and mature trees could be reduced with more effective legal protection by identifying and mapping significant tree cover and mature trees prior to development, planning residential development so that they can avoid clearing as much tree cover as possible instead of resorting straight to offsetting, and designing green space with residential development, designing green space within residential developments so there is adequate separation between mature trees and people and infrastructure. Okay, on to the next section. So bird and bat community response. Don't want to reiterate too much, but I just want to emphasize that mature trees are keystone structures for biodiversity in a range of environments. Previous research in Canberra by Cara, or previously Stuggle, has demonstrated the abundance of large trees in urban parks had a positive relationship with bird species richness, abundance, and community composition. In other research by Darren LaRue, he found isolated trees supported significantly more bird species and individuals compared with trees in stands of vegetation. He also reported 29% of bird species were recorded exclusively at large trees. Some of the key features that make them attractive, we've talked about that. So going back to the hollow importance, so Australia is home to 114 hollow-dependent bird species and approximately 300 hollow-dependent vertebrate species. Globally, it's estimated there's between 4 and 11% of birds that require cavities, but in Australia, it's about 15%. For microbats, we have about 68 species, and most of those will use tree hollows for roosting. The big issue is that hollows will take a minimum 120 to 220 years to form, and that's generally just for the small hollows that would fit gliders or rosellas and things like that. Okay. To address, so for the bird study, the aim was to identify the landscape context in which trees serve as keystone habitat structures for birds in urban areas. We had 3 research questions. Which tree sizes act as keystone structures for birds in urban areas? In which landscape context do trees act as keystone structures for birds? And for which bird species are trees keystone structures? For microbats, it is quite similar, but we wanted to explore a range of bat community metrics across 2 contrasting areas of Australia, which is the same for the birds, but for microbats, it's a little bit more important because there's been less work done on microbats in Canberra. So comparing Southeast Queensland, where it's subtropical sclerophyll, with Australian Capital Territory characterised by temperate grassy woodlands was important. So we had 2 research questions for the bat research. Is the richness and activity of insectivorous bats in urban environments associated with the occurrence of large trees? And what is the landscape context in which large trees have the greatest benefit for insectivorous bats in urban environments? So that's also a key distinguishing point, is that we looked at microbats that are purely insectivorous. This does not include flying foxes or megabats. Okay. We sampled across 83 sites from ACT and Southeast Queensland, so primarily the Gold Coast, because we wanted to look at recent development areas as well to align with our first paper. The sites were stratified by state and then approximately by number of mature trees, so that we could sample sites that had only 0 or 1 mature tree through to lots of mature trees. The sample plots are in greenspace at recent residential developments at those varying tree densities. For birds, we surveyed twice per site using 15-minute, 50-meter radius point count surveys. And then for bats, we set up detectors at 2 per site for a minimum of 3 consecutive nights. Okay, these are some of our bird results. So to help explain this, we ran generalized linear mixed models again, and we tried to have a look at what tree size had the biggest impact on those birds. So we sorted the trees per site into size bins of 40 plus, 50 plus, 60 plus, diameter bins up to 100. And basically what we found was that for ACT, we've got 80 centimeter trees and up was most important for bird species richness. And then trees 70 and up was most important for bird abundance. Whereas for Queensland, it's just trees 40 and up was consistently the most important. Okay, so for each one, we've looked at the 25th percentile median and 75th percentile level of tree cover. So in the ACT, those values only reach 8.4% tree cover versus Queensland, where it gets up to 57%. And what we're looking at is as the number of trees increases, generally so does the bird richness or the abundance, but that relationship is stronger when there is less tree cover. So what that means is if you have one tree that is standing out on its own, you're more likely to have a sort of magnified effect with all the birds coming into that one spot or that one tree, as opposed to having trees in a cluster or a group of trees where that sort of value is dispersed a bit more. This is something that Darren showed a bit with his research, but otherwise it hasn't really been shown very strongly before. Okay, this is using multi-species occupancy modeling. So we wanted to look at the effect of the number of trees greater than 70 centimeters in dBH out on the presence of the 17 most common bird species we recorded in the ACT. And what we found is that 9 of the 17 had a significant positive effect, indicated by the large filled dots. 7 of those were hollow-dependent. So that includes the crimson rosella, the eastern rosella, the galah, the red-rumped parrot, the striated pardalote, and the sulphur-crested cockatoo. In Queensland, we didn't have as bigger clear impacts, but you can see 2 birds were still significantly impacted positively by those trees, which was the noisy miner and the rainbow lorikeet. But most of the birds still had that positive impact. It just wasn't quite as strong. For microbats, so we recorded 20,000 bat passes for microbats, and that was identified to 16 species and 4 species complexes. In the ACT, we found 12 to 15, depending on the complex ID, out of the total 21 species, which is pretty impressive that they were all hanging out around urban areas. We found positive associations between 5 of the different bat metrics with the number of large trees greater than 50 centimeters in dBH. So looking at this figure, we basically ran it all as the ACT and Southeast Queensland data together. And we looked at a predicted mean per night of total bat richness on the left and total bat activity on the right. So ACT is in purple, Southeast Queensland is in green. So there is more bat activity and more bat species for Southeast Queensland, which generally just comes from the warmer climate. They prefer that. So bat activity is just described as the number of calls. So that means there is potential that it's just one bat circling the detector, screeching constantly. Or you might have 50 different bats going past. So that's why we don't use an abundance measure for bats. We talk about the level of activity. Okay. So we found pretty similar patterns to what we did with the birds. So number of trees greater than 50 dBH on the bottom. We've got ACT down the left, Southeast Queensland on the right. And what we did was we split the bat groups into the edge adapted, which means the microbats that are basically their wings are built so that they can flutter and hover in amongst foliage or get in close and glean off the foliage, versus the open adapted bats, which are those that fly over the canopy. So very different flight and foraging styles. But we found they both had these significant patterns, and basically with the tree cover, they did the same thing. So if we had one tree out isolated, so in an area of 0% tree cover, that value was magnified compared to trees that were in amongst other tree cover where they weren't seeing as big a sort of value. Okay, so basically what we found is that large trees are more likely to act as keystone structures for birds in landscapes with little tree cover. And the value of large trees for bats, particularly the richness of clutter adapted bats, that was one of our strongest findings. That's enhanced when large trees are isolated. What are some of the reasons this might be happening? So scattered or structurally isolated large trees are not functionally isolated for birds and microbats. As they're highly mobile, the value of large trees as habitat does not diminish, even if they're in apparent isolation. Isolated large trees are more easily discoverable by birds moving through the landscape and microbats, compared with large trees that might occur in a stand with a big group of trees. Large trees that are apparently isolated in urban environments might also represent that perfect juxtaposition of habitats for nesting, perching, and feeding for many of the urban adapted bird species we have. Okay, coming up to our last section, so quantifying the risk posed by Australian eucalypts. We set out to investigate branch drop in Australian eucalypts to inform and build upon the quantitative tree risk assessment method. We sought to determine how branch fall in eucalypts varies with tree form, size, and species. Using this information, we investigated what risk is posed to people and infrastructure by eucalypts in different urban settings. So for our branch fall component of this study, we recorded or monitored 102 trees measured across 20 species. We generally used citizen science data to help out, as well as we had research assistants and me going out to go and check on our trees. So basically, one of the biggest difficulties was this, is that we needed trees that were in locations where the branches weren't going to be picked up and taken away, where they weren't going to be part of a really dense cluster of trees, so you couldn't tell if the branch fell was related to that tree or not. Trying to make sure people were dedicated and actually going back and measuring, collecting those branches, it made it a lot more difficult than we thought. We also had trees that were cut down during our survey period. So we started out with like 150 or more, and it just kept getting cut down. But 102 is not bad. Cool. And we ended up with 339 branches dropped. 323 of those were in the small size bracket, which means they only hit 10 centimeters in diameter. 16 branches measured were over 100 millimeters in diameter. We did take measurements of sort of the details of the trees where they were. So we looked at like slope, aspect, canopy width to get an idea of senescence and all that sort of thing. And then we also looked at whether they had an intact or senescent canopy. So to make it sort of easier and clearer for the citizen scientists and things, we said that the senescent canopy contained basically reasonable amount of dead wood. So unless it was just one or two individual branches, we'd class it as a senescent canopy. And then to record the circumference of a drop branch, we'd ask them to look at the widest point and then just basically check the circumference, and we'd calculate that back to diameter. We also didn't want to include branches that were dropped previously. They needed to be dropped over a time period where we could monitor them. So if the volunteers went and had a look, we needed to clear out any existing branches and then only measure over the year or longer period that we were recording the branch for. Okay, so looking at that, again, we ran some generalized linear mixed models, and we were hoping to find maybe some relationships between the BBH or the crown width or species, but nothing else really came through except for the intact canopy versus senescent canopy. So looking at this, we have small branches and large branches set up here. The reason we have these branch sizes is because Ellison's work, the QTRA, he describes, I think there's about 5 different size brackets with their associated impact potential. So we wanted to make sure that we matched up with that. So looking at that, basically we have small and large branches, intact canopy in green versus senescent canopy in brown. And then the error bars is showing the 95% confidence intervals. Basically what we're saying is small branches are more likely to drop, and senescent canopy, trees with senescent canopy are more likely to drop branches full stop. Now, we applied that to make this big risk matrix, and I'm going to show the interactive version. Assuming it opens. There we go. Oh, okay. So hope you can appreciate that I'm very proud of my matrix. It's
Very nice, very nice.
So this is a lot to take in, but basically what we're looking at is the probability of branch fall ultimately. We have split it into 4 boxes. So we have small branches on the bottom, large branches on top, intact canopies down the left side versus senescent canopy on the right. Within each box, we have lower, mean, upper for 95% confidence intervals. And then down the bottom, we're looking at the target occupancy scenarios. So you can see our risk rating colors here. So basically, this is trying to draw it into standard risk avoidance sort of work. So no one is willing anymore to put a number on it, but it used to be 1 in 10,000 was the acceptable risk level. So we've said if it's less than 1 in 10,000 chance, you're broadly looking at an acceptable risk. A tolerable risk is between 1 in 1,000 and 1 in 10,000. And then if it's less than that, it's probably an unacceptable level of risk. So now looking at this, that goes green to red as you get longer occupancy. So the target occupancy scenarios are based on how long a person or infrastructure is present under a tree. So if we're looking at a scenario such as having landscaping under a tree, or an off-path scenario where there's very few people, it's generally pretty safe because it's not going to hit someone. And then as you spread it out, it gets more and more risky. So we'll have a look. Let's go back to this. go. So looking at the scenarios on their own, okay. If we have a tree that is over fixed infrastructure, such as a building or power lines, the target occupancy is 100% because there is always something present. That means your risk is pretty much going to be unacceptable because it's pretty much likely that if that tree drops a branch, you know it's going to hit something. If we're looking at a busy footpath scenario, such as Hyde Park in Sydney, the true pedestrian frequency was between 4,500 and 5,000 pedestrians a day on average. That means your risk is somewhere between unacceptable and tolerable, depending on the canopy health of those trees. Now, if you have a tree that's out on a walking track on a reserve and it starts to lean over a bit, if you've got targets, so let's say you've got roughly 260 pedestrians per day, such as the accurate tracking through Mount Taylor, your risk is going to be a lot more okay. It's a lot less likely to hit someone. And there's also the idea that people are more accustomed to more risk when they're out in nature as well. Now, what we're trying to advocate for is using landscaping or other methods to try to limit the time people are spending under trees if you're a building manager. So if you can reduce the people under it to an average of 1 to 5 pedestrians per day, your risk is very, very low because you've removed the target. That means the branches are still going to fall, but if there's no one there to get hit, then the risk is ultimately dropped or eliminated. Now, one suggestion might be to just cut out all these senescent branches and then you're going to be really safe. But Alex Holland and Phil's work and other things have shown that 15% of preferred branches for birds are dead limbs. They love these lateral flat limbs and they're like the dead branches. I was going through all my photos of all the birds in Canberra and they are all on dead branches. They love them. So it's not really ideal to just say, let's just cut off all the dead branches because then you're taking away all these spots these birds need. All right. Ultimately, we're saying isolated or scattered large trees are keystone structures in urban areas, as they offer disproportionate value for birds and microbats. Whilst the notion that trees need to be in clusters to be of value persists, important wildlife habitat will continue to be lost. Our research reinforces the evidence that retaining isolated large trees offers an important opportunity to protect biodiversity values. There is greater capacity to retain more trees within urban green space. If we can use thoughtful planning and appropriate management, more mature trees can be retained in spaces where they don't pose an unacceptable risk to people or infrastructure. Thank you.
Thanks, Cara. That was fantastic. Very nice slides.
Thank you.
Do we have any questions or comments? I'll go with John first. Paul's always the first hand up.
I just wanted to confirm, you're not going to advocate cutting down all those trees in Hyde Park?
Yeah, I think we should. I think that's actually the only solution, is that we cut them down. No, this is the problem. And when I presented this at Gin and Dairy, then a heap of people came out and they're like, oh, so you just should never sit under a tree again. And we're like, no, but you accept that risk. So if it's a place where we're starting fresh and they get to go and design things, the idea would be to not put a walkway directly under some old trees. So yeah, do not cut them down from Hyde Park. But if it was going to be a concern, they could move that pathway away.
But if you go back to that risk thing, well, you notice that it just means you manage, in a situation like that, you manage the tree more intensively. And then in the ACT, trees in those types of situations are taken out after 60 years. They're not let to grow old, you know, so I mean, this, where was Hyde Park? It was here.
Hyde Parks, yeah.
Yeah, so you can see that it's, in the intact canopy, you know, you've got sort of tolerable risk at, for the small branches, and, so, yeah, so it's a matter of managing the tree, I guess, in those situations. You don't leave big fallen mature trees in those situations, but yeah. I mean, is that what you sort of?
Yeah, I think so.
Yeah, I think it's unsustainable that we expect to leave a big old senescent eucalypt hanging over the path in Hyde Park. I mean, it'd be, yeah.
I think they should just move the footpath.
So Saul, yeah.
That's great, thanks.
Thank
And obviously I've seen most of it before, but the newer part to me is the tree fall,
Okay,
the
yep.
branch fall stuff. And I was thinking about, you know, if you, I mean, I know you're using standard sort of ways of thinking that landscape designers are
Yeah.
thinking of. But if we think about the real world, there's two things seem more nuanced than a simple crushing numbers. One is, which I presume is captured, is that crushing a car, although bad, is much less problematic than crushing a live person.
Yes, yeah.
And if you think about the crushing a live person, killing a person, then surely, if it's the case that most of the branches are falling in storms,
Yeah, yeah.
and certainly for the branches that you were counting, so not certainly, I think for the branches you were counting, a lot of which fell in storms,
Yeah.
then perhaps the exposure is even lower again,
Probably.
because people aren't standing out in the middle of a storm
Yeah.
under big trees. So I wonder if further research, you know,
Could look
get
into that.
deeper into that nuance and think about what are the behaviours you're really managing
Yeah.
for, and presumably we could tolerate a few crushing cars. Insurance companies might not love it because they don't want people to be killed, but the way that people move is very different to the way that infrastructure moves. So have you got any thoughts about that?
Yeah.
The storm drop sort of issue and how that changes?
I think that's it. It's like, obviously only had a certain amount of time to talk, but what we want to do is basically, this is just trying to give some of that quantitative look into how much the branches are falling. We know that they're not falling constantly. We know that there's greater risk if you are out in a storm and it's really windy. Or another point is when it's been severe droughts and the trees start to drop their own limbs, then that's going to pose a bit more risk. But ultimately, there is a lot of management that could be done, such as using the signage to say, you know, if you're sitting under a tree and when it's really windy, that's on you. Like, you take the risk. We did, so in Ellison's work, he looked at the cost associated as well. So they looked at the value of what's being hit, including trying to put a value on a human life of somewhere around £1 million. And I was like, that is too much. I'm not going to try and associate a value. There was also another person that did a study looking at just sort of what we did, but from the angle of looking at what cars are coming through under a tree. So it was like trying to say the target issue of these trees, of a tree sitting there in a spot. And I think it was something like a school drop-off where all the cars would come through. And he basically was saying all of these cars are crappy old cars and the value is not that good, so it doesn't matter. So people have looked at the value side a little bit more. I think we're just trying to show it as more like a, this is what happens if you've got lots of people coming through, and like the issues with the residential development, people love to live near these big trees, but they don't want it on their property. They don't want it to hit their house or their car. So if you can retain it in a nice green space, like it, some of those pictures in Gin and Dairy. Where are we? Like that one. Then it's going to be safer and it's nicer for everyone that lives in that environment as well. Well, I hope that answers a little bit.
Yeah.
So to go back to the risk matrix a bit, I mean, one thing, because Elson does talk about this, that the reality is that most of those are dropping storms, and so.
Yeah.
But even looking at the averages, you know, average probability of rainfall, you know, in the confidence limits, which is spread across up to 12 months, a long period of time.
Yes, this is, yeah,
Yeah.
probability over a year.
It's the tolerable risk extends much further than management would suggest.
Yeah.
You know, so you know, they're much more, and I guess, you know, I was talking to the guy, you know, Ken Third, who is the Singapore National Parks Authority, and National Parks Board. And so he said the hardest part of that job is when someone gets killed by a tree.
Yeah.
You know, and of course, managers going to be risk averse.
Yeah.
You know, if I was in that
Only had to happen
position,
once.
I'd be risk averse. But it is amazing that, because we've done all this work at Ginninderra to put landscaping around those trees. In actual fact, the risk is so acceptable if you
This is-
just have no
so it's like-
landscaping. You know, as long as you don't have a path.
Less than 10% chance of a large branch falling, or less than 20% chance.
Yes.
So
But these ones can kill you too. That's
if you're really unlucky.
yeah. I think elephants in that 10 centimeters is big. You know, like that could really kill you. But anyway, we'll move on. I think George was next.
Yeah, thanks. I've got 3 comments actually. One is that camping under trees, I've been involved in scouts for years. You don't do it. And you
Yeah.
tell the scouts you camp under a tree. They've got the name of widow makers for a reason from the old timers. Second point is that we've got brittle drums in our street and they'll come down in hot weather.
Yep.
A really hot day, the sap must expand or something. There'll be an explosion.
Yeah. Okay.
And you come out in front, there's a branch across the road.
Yeah.
So it's not just storms.
No, but I guess
Yeah.
on average, you do get more branch dropping storms. I think that's pretty well known.
Oh, yeah.
Yeah.
We're not
Except
talking about
that-
full tree.
Yeah,
You'd be surprised how many of them come down.
no.
2 trees have come down within a couple hundred meters of our place on a hot day.
Yeah,
I mean, a really hot day.
Yeah.
And the other one is to talk about risk aversion, the tree police are heavily risk averse. We
Yeah.
complained that there was a branch going over where we park our car.
Yeah.
We don't have a garage. And so eventually they came along to cut the branch off. They had one look at the tree and looked inside and said, oh, it's rotten inside. They chopped the whole tree down,
Yeah.
which I didn't want. I mean, I
Yeah.
wouldn't have even called them if I knew they were going to do that in the first place.
Yeah.
And that's why having a bit of, I think, Cara, having a bit of figures around them and stuff, it protects them, you know, because, you know, from talking to people, you know, if you come out to inspect a tree as a government representative and George comes out and says, this bloody tree, you've got to remove it, they feel pressure to do it unless they
Yeah.
can fall back on some, you know, quantitative sort of data.
I just wanted to chop the branch off. I didn't want to chop the
Yeah. I'm sorry.
Yeah,
Yeah.
Or what if you bring up a picture of a nice old tree in a public area and then it's suddenly gone the next week?
Oh, yeah. I gave a presentation, sort of a theoretical, you know, before Cara had a data about, you know, how you manage risk. And I had this picture of a tree up the summit to Mount Majura, very heavily used track. There was this tree hanging over with a huge fire scar at the base. And I said, look, our tolerance of risk varies when you're in the suburbs around reserves, you know, and the next time I run up there, the bloody tree's been cut down.
I've been a little plug with doing that.
Yeah. So I don't know if it was related to that thought. So anyway, Cara.
Guess, 2 things, sort of in terms of risk, like, what's like, if we're quantifying like human death, tree branch, how does that compare to like, in reality? It's like, if that's like 1 in a few million.
Yeah.
Compared to like other fatalities, like, is it really a risk? Like,
It's very low. It's very low. I've got some bits I'm putting together for my discussion, and it's sort of like looking at the risk of death is like it's pretty minimal from trees. Like people have studied that from like other countries and things. And then the other thing is what's acceptable is like a 1 in 10,000 risk is related to, I think, driving in your car for 40, it's like 40 kilometers or 40 days or something. Like it's pretty, really common, really average. So it's like to even say what's in there, anything in the green is something that you're and sort of acknowledging at all times. I think the problem with the property developers and those sort of things, they don't want to wait until someone dies as the major risk. They want to stop any complaints, anything further back. So that what makes it a bit more difficult.
In terms of like property development, would you say the ideal scenario would be say that you have some hectares that is proposed for development, they should be looking at what that development should look like in conjunction with the mature trees that are there rather than trying to retrofit?
Absolutely. Yeah, that's pretty much putting everything wrapped together is like, yes, please, for the love of God, look at this first. Like you can't replace mature trees. So if it takes 150, 200 years to have one hollow, that's so vital for so many threatened species. So it's like for them to come in and be like, let's just clear it all and leave a little strip of trees on the edge where people drive past so it looks nice and bushy. That's not enough. So we're trying to push really hard to get them to look at what trees are in place, design around that by keeping these trees in green space.
Is that something that's being done?
A little bit.
Yeah. So we had another law science student do a project recently where she interviewed various people around the ACT government. And one thing that Gin and Dairy did where we piloted this is that they shifted their planning for mature trees much earlier in the process of the master plan phase, was it? It was too early. And through these interviews, we found that ACT government usual practices is to consider mature trees quite late in the planning process. And so the Suburban Land Agency have actually now, who actually paid for that work, have now taken on that advice and they're starting to shift all new developments in the ACT have got to consider mature trees right up front. So,
and that doesn't happen anywhere else. Like in Australia, it's all pretty shonky. You're lucky if you get a little strip left. So I think Phil's work with Gin and Dairy has been great because the first
and yours, Cara, it's
that first stage where you went and talked to them and they're like, yeah, we're saving 20%, we're doing a really great job, and Phil's like, no, that still sucks, do more. And then they got it up to 80%, which is 92%. Huge. 92% now with all the other suburbs. So it's like, that's huge. And it is different and a little bit easier here where you've got scattered paddock trees. When we're looking at New South Wales and Queensland, they are clearing just actual forest. So for them to go and sit through and pick out which trees are nice to keep is harder, but looking at Canberra,
the example of Carrington Grove is interesting because I grew up in that area.
Yep.
And I like witnessed the whole clearing.
Yeah.
The whole road over a span of like 7 years.
Yep.
And it was like went from like rural bushland to like massive urban sprawl.
Yeah. And there's no facilities or anything out at these places yet. Like we've got it on the Gold Coast. If you drive on the highway, you go through Coomera and Helensvale and Pimpama, and it's just huge areas of clearing. And then they just keep it cleared because they're like, oh, well, it's cleared now before we get a development approval, but it's ours now and it's easier to get through. And that's an area that is heavily full of koalas. And koalas get all of the attention. They've got all of the protections and all the help and everything, and they've got their own dedicated koala group there, and it's still not enough. I've been out to one of the spots where there was 2 developments next to each other and they saved 3 trees between them, and there was a koala sucker. I'm like, good, where's he going to go? He just gets to live off these 3 trees until he devours all of the leaf and then dies. Like, it's just really sad. But
so there's a question here in the chat from Leah Warburton. She says it appears that you're only looking at the target risk and not other factors like likely failures. So there are just more factors to consider besides just the target.
absolutely. Yeah.
Comment on that.
No, that's okay. Yeah, there is absolutely a heap of factors. So that was something that we tried to look at a little bit with our analysis. But nothing else really showed as having a big impact on whether the tree will drop a branch or not. But we're also not saying this is the be all end all. Like, we can understand that there's a lot of factors that go into posing a risk of that branch failing or that tree failing. And that's not something that you can really capture in just one short study. But what we'd be advocating for is sort of in future, if like a council wanted to look at this for their own trees or for a new development, they could go in and try and replicate our study so that they could get a better idea of the risk profile of their local trees. And that might be something that would help in the future as well.
Okay. Oh, John, yeah.
Just wanted to say that it's also within the context of humans interacting with nature, and then there's the benefits of humans interacting with
Yeah.
nature. And if we take away all the trees, there's a risk there that humans are from having that time in nature. So
Absolutely.
that's something we should discussions.
Yeah, as you said, you know, the mature trees have links to property value, you know, improved property values, and that's reflects people's values.
I think,
Whenever I'm interviewed about trees, you know, on radio, they do callings, and you get so many people. So people are so passionate about this.
Yeah.
It's amazing. Yeah.
Well, this is it. There's so many people with that link to their favorite sort of old trees or the birds nesting in that tree. So I think I'll definitely include something to describe that, where it's like it's important for these people to have that sort of connection to nature, as well as the economic values of keeping them and all of these things. And it's sort of like if people need that access to local green space. And I think that's part of the Canberra planning, isn't it? That you're meant to be 400 meters from a park or something.
The UN says 300 meters is the
Yeah,
recommendation.
so it's sort of like it ties in with that too. So if you make heaps of these little pocket parks, it's really good for wildlife, it's good for people.
Have you thought about doing sort of a conversation article that really does that the two sides thing? The benefits of keeping trees and then the flip side of the
I'd be interested in
Great idea.
add it to my list.
All right. Look, one final quick question. If you were to do your PhD again, what would you do differently?
Not have COVID in the middle of it. Sorry, like 3 weeks in. I don't know, probably a bit more field work, but more field work, because I missed out on doing the birds and the bats because of COVID.
Oh, we had to out
from Canberra. Yeah, I only got to do my half on the Gold Coast, but I think everything's done pretty well. Like, it's gone pretty much as good as it can with heaps of things going wrong in the middle of it. So
Okay, well done, Cara. You're nearly home now, so